Okay, so here's another uh, high-fat diet or ketogenic diet video about the risks of a high-fat diet. So, starting with Megalin, uh, basically the cubulin binds to the vitamin B12 intrinsic factor complex, and the cubulin has to anchor, and if it cannot anchor because of megalin deficiency as a result of high fat or keto diet lowering megalin, then that's going to lead to vitamin B12 deficiency. Now, what's going to happen as a result of that B12 deficiency? There is going to be a less, or actually probably no cysteine, as well as no glutathione. Therefore, AGEs, advanced glycation end products, are going to accumulate and possibly make the ECM, short for extracellular matrix, to be stiff and rigid, and then the cancer cells are either going to stay stuck in there, or the immune cells are going to be excluded from the ECM, and then the immune cells cannot get in to attack or battle it out with the cancer cells. Okay, so vitamin B12 deficiency will also lead to a cysteine deficiency, and then metallothionein cannot properly store or transfer zinc, because metallothionein basically deals with the metals such as copper and zinc. And metallothionein will be deficient if cysteine is also deficient. Okay, so a zinc deficiency as a result of high-fat diet, unless if there is a way to mitigate it or counter it, or if there is a way around the negative effects of a high-fat diet, which I will do some more research on. But zinc deficiency as a result leads to impaired thyroid hormone. As a result of that, that can also have negative effects on immune cells and T cells. So zinc is required for enzymes involved in producing thyroid hormones, such as T3 and T4. Zinc deficiency means reduced hormone output of the thyroid. Zinc supports deiodinase enzymes, especially D1 and D2, but low zinc, less active T3, which is the biologically potent hormone. Okay, so T3 is supposed to bind to its receptor, or the nuclear receptors, including thyroid hormone receptors. But if zinc is deficient, then there's reduced binding of T3 to the thyroid hormone receptor, therefore leading to functional hypothyroidism, even if labs look borderline. Now, my channel is mostly focused on cancer and immune system, so I won't be talking too much about the thyroid. Okay, now, low thyroid hormones as a result of zinc deficiency, it can affect the immune cell nutrient uptake, because T3 are major regulators of cellular metabolism, including immune cells like T cells, macrophages, and neutrophils. And when T3 is low, there is reduced glucose uptake, because T3 cannot upregulate glucose transporters such as GLUT1 and GLUT3. And if T3 is low, then this cannot enhance glycolysis, and glycolysis is critical for activated immune cells. So low zinc, low T3 thyroid hormone, therefore no glycolysis for immune cells. And low T3 affects glycolytic flux, reducing glycolysis that immune cells depend on. Okay, so low T3 means low GLUT expression, low glycolytic flux. Immune cells struggle to switch into active mode. The result is reduced proliferation of T cells, which could be good to reduce autoimmunity, which is where the healthy body tissues are being attacked by excessive T cells. But if there are not enough T cells, then cancer cells go unopposed. And then also impairs phagocytosis and killing by macrophages. So no zinc means dying tumor cells are releasing ATP to make adenosine that suppresses T cells, because the macrophages are not engulfing or cleaning up the dying cells and debris. Okay, this also affects amino acid uptake, including arginine and tryptophan, such as general amino acids. T3 increases amino acid transporter expression. T3 supports protein synthesis and immune signaling molecules because T cells, they do need protein synthesis as one of the way that they activate and attack cancer cells. But low T3 results in reduced amino acid transporter activity. So low T3 also means reduced cytokines, receptors, and enzymes. Okay, in the tumor microenvironment, tumors, they deplete arginine and they take arginine away from T cells. Now, low T3 thyroid hormone can actually make this worse because uh, low thyroid hormone means a low arginine uptake, therefore reduced nitric oxide synthesis. Because arginine is critical for nitric oxide production in macrophages, and nitric oxide is also needed for T cell proliferation. So the T cells will be reduced in numbers while the tumors are stealing arginine away at the same time, which is not a good situation. So low T3 also means reduced tryptophan, and tryptophan is used for the kynurenine pathway that is responsible for immune regulation. So low T3 means dysregulated immune tolerance pathways. Okay, so low T3 will also lead to an energy deficit in immune cells, especially memory T cells and macrophages, because a normal T3, its role is to stimulate mitochondrial activity and increases fatty acid transport. And low T3 means low or reduced fatty acid uptake and reduced mitochondrial respiration. So that means no fatty acids for immune cells because immune cells, they do use fats for fuel. One of the receptors on the immune cell is the FATP receptor, which I've made a video on that already. You can watch that if you want. Uh, Also, low T3 uh, means reduced mitochondria, also means less ATP for the immune system because the immune system requires a vast amount of ATP. So, a high fat diet or keto diet reducing megalin and then leading to zinc deficiency can have a huge negative impact on the immune system. So that's it for the video. If you're interested in more future videos and more mechanistic insights, because I do a lot of these, make sure to like, comment, share these with your friends and family, and subscribe. Keep it locked in here on my channel, and I'll see you in the next video.